Sir Isaac Newton first stated the laws of motion in Principia Mathematica back in 1687. Today, those laws are seen as facts. When something moves, it has to push against something else. But a new study may have fundamentally challenged the law of the conservation of momentum, at least in curved space. When humans, animals, and machines move, they always push against something, whether it's the ground, air, or water. Until recently, physicists believed this to be a constant, following the law of conservation of momentum. Now, researchers from the Georgia Institute of Technology have proven the opposite. When bodies exist in curved spaces, it turns out that they can, in fact, move without pushing against something. The findings were published in the Proceedings of the National Academy of Sciences. In the research, a team led by Dr. Zeb Rocklin, assistant professor at Georgia Tech, created a robot confined to a spherical surface with unprecedented levels of isolation from its environment, so that these curvature-induced effects would predominate. Then, the team let the shape-changing object move on the simplest curved space, a sphere, to study its motion in curved space. To confine the object on the sphere with minimal interaction or exchange of momentum with the environment in the curved space, they let a set of motors drive on curved tracks as moving masses. They then connected this system to a rotating shaft so that the motors always move on a sphere. Air bearings and bushings supported the shaft to minimize the friction, and the shaft's alignment was adjusted with the Earth's gravity to minimize the residual force of gravity. As the robot continued to move, gravity and friction exerted slight forces on it. These forces hybridized with the curvature effects to produce a strange dynamic, with properties that neither could induce on their own. The predicted effect, which was so counterintuitive it was dismissed by some physicists, indeed occurred. As the robot changed its shape, it inched forward around the sphere in a way that could not be attributed to environmental interactions, said Rocklin. The research demonstrates how curved spaces can fundamentally challenge physical laws and intuition designed for flat spaces. This research also relates to the impossible engine study, said Rocklin. The impossible EM drive is supposed to move without any propellant, generating thrust just by reflecting microwaves inside the device, in a way that would violate the law of conservation of momentum and other laws of physics. That engine was indeed impossible, but because spacetime is very slightly curved, a device could actually move forward without any external forces or emitting a propellant, a novel discovery. Ultimately, the principles of how a space's curvature can be harnessed for locomotion may allow spacecraft to navigate the highly curved space around a black hole. Thank you for watching, and don't forget to subscribe.